Good morning, Portia.
Good morning, Azia. And let's review the first question. Again, these are questions of the type that you might see on the final. Basically, we finished all the material for the final. We're now up to review. We have review today, we have review tomorrow. I'm just trying to go through as many types of questions that you might see on the final. Again, if you have any particular examples or type of examples you'd like me to go over, make sure you let me know either by email or by talking to me in person. It's fine. Just say, really, can you go over graphing of lines? Something of that nature. And I definitely can do a review of anything that you would feel you need review on. So I think it was Ashley who sent me an email that she said she really, and the reason I haven't given homework on this on Delta Math is because the type of problems that they have on Delta Math are much harder than what you need to know. So I felt it would just be more confusing rather than that. That's one of the problems with Delta Math. They really do a for our purposes, it does a great job because most of the topics that are covered the way I want them to be covered and have the type of questions that you have to know how to do. The trigonometry is not so good, the conic sections is not so good, but basically everything else that we did cover this term, the homeworks in Delta Math really were very on target to what we need to know. Again, those of you who have not completed at least 15 of the homeworks. Now, when I say completed, you don't have to get 100 on it. You just have to do it. And you have to do at least 15, and there were 21. All you have to do is open up your account. It'll show you if you need something. If you don't, you count up how many you've got credit for. They're the ones that you've worked on. If you don't have 15, I know I sent you an email, but if you should be on your own able to tell me you to do get those 15 done so you can have the complete amount of credit for out of the 15 points that you get 10 for homeworks and 10 and 5 for participation. That's what the Delta Math is all about. So I didn't expect you to do every single one of them. You get extra credit if you do more, but it doesn't matter what grade you get on that homework. I don't care if you got a 40 on the homework. It's did you do it? Did you make an attempt? That's what homework is about. Obviously, the grade, then there are 25% of your grade is the quizzes and tests that I have assigned. There were 2 tests on Blackboard, and there are 4 quizzes on Delta Math. That's aside from any practice tests, anything else, any midterm, etc. That is worth 25% of your grade. You need to have done 5 of them out of those 6. If you did all 6, I'll drop the lowest mark. But you must do at least 5 because your grade, I add up all those marks and divide them by 5. And if you only have 4 marks, one of those grades is going to be considered 0, and you're going to end up with a much lower average because you did not do all the work. The the midterm is 25% of your grade. That's, of course, done already. Most people did nicely on it. And the final exam is 35% of your grade. And I really do it by the numbers. So,
Um,
yes,
Professor, good morning. This is Jonathan, by the way. You know when the last day of classes before the final exams? What's the last day of classes, if you know?
tomorrow.
Tomorrow? Oh, sure. Okay.
As far as I know, tomorrow. If you, I know for us it's tomorrow,
Oh,
but I don't, your other classes, I think that this is the end of the term. The 14th is the last day of class.
Okay.
Okay, and finals do start next week.
Mm-hmm.
So make sure you know where your other finals go. As I have our final again is a week from today. In other words, today is review, tomorrow is review. If you have any questions, you can always email me a question and I can help you with it. But really, I would say get all your work done so that you know where you're going. All right, so let's look at question number 1. I have a right triangle. Here's my right angle. Here's the angle theta. And they're telling me this side is 10 and this side is 26. In terms of theta, in terms of this angle, let's remember, this is our opposite side. This is our hypotenuse. And this is our adjacent. Be very careful. You have to know where the location of the angle is. If you're talking about this angle over here, then this becomes the opposite and this becomes the adjacent. The opposite and the adjacent vary depending on where your theta is placed. Most of the time the theta is down here. So this is our opposite and this is our adjacent. But if your theta is in a different position, if it's up here, then this becomes your opposite. This stays the hypotenuse because it's always opposite the right angle, and this becomes the adjacent. Now, they asked me to find the sine of theta. And we know sine of theta is, we get from SOHCAHTOA. The sine is the opposite over the hypotenuse. So it's this side over this. So we're okay in terms of the hypotenuse. The hypotenuse we know is 26, but they didn't give me the opposite side. They gave me the adjacent side. But I know I can figure out what that adjacent, that third side is by using the Pythagorean theorem. A squared plus B squared equals C squared. Now, we would have been lucky if they would have put the 10 over here, we would have been lucky, but they didn't. So let's figure this out. This is A squared plus 10 squared equals 26 squared. And I'm taking out my calculator. A squared plus 100, that's easy. 10 squared is 100, but 26 squared, I don't know by heart.
676.
Is 676?
Yeah.
Thank you. And
And
then
676
subtract
minus 100 gives 576. Is 34, 576.
Let's go here. So I get that A squared equals 576.
Yeah, so the square root of 576 is 24.
Right, perfect. And notice we only use the positive answer because because we're talking about sides of a triangle. So this side turns out to be 24. So when I do SOHCAHTOA, when I do sine is opposite over 24, the opposite over hypotenuse, I get 24 over 26. Now, usually they want these answers simplified if you can, and we can reduce this to 12 over 13. So the correct answer for the first question is 12 over 13. Does anybody have a question about that?
Professor, it's 12 over 13 because you simplified, right?
Right. I reduced the 24 over 26. You see, I could divide the top.
Plug that into the calculator and it will give me that?
Yeah, sure.
Okay, thank you.
Remember, your calculator might give you the decimal version. It depends on how your calculator is set up. But it can also reduce it. All right, so now let's look at the second question. which is a similar question. We have a similar triangle. We have the theta here. We have this side is 2 and this side is 7. Let's again write what the sine, what the opposite, the adjacent, and the hypotenuse are. So again, this is going to be our opposite side because it's across from the theta. Here's my right angle, so this is the hypotenuse. That is 7 because, and of course this will be my adjacent side, which we don't know. And the question is, find the secant of theta. Now let's think. The secant, it's one of the secondary trigonometric functions. It starts with the S, so its partner has to be the one that starts with C, so it's sine cosine. So it's the reciprocal of the cosine. Somehow, I am. Yeah, it's on the right. And I know the cosine is ka, so ka, Toa. It's the adjacent over the hypotenuse. And what we're going to do is we're going to find the adjacent over the hypotenuse. And then we'll go to the secant by just flipping it over, taking its reciprocal. Okay, so again, I have the opposite in the hypotenuse and I need the adjacent here because I know the hypotenuse is 7, but I don't know what the adjacent is. So again, I do my a squared plus b squared equals c squared. And it's 2 squared plus b squared equals 7 squared. Okay, let's do this over here. So it's 4 plus b squared equals
Plus 49. You know, 49. Yeah.
And now I have to subtract the 4 because what they gave me was a hypotenuse. So that gives me b squared
Equal 45.
and the b is the square root of 45. So therefore, we know the cosine is going to be, this is the square root of 45. So the cosine of theta, let's do this over here. The cosine of theta is the adjacent, which is the square root of 45, over the hypotenuse, which is 7. But again, I didn't ask you for the cosine. I asked you for the secant. Find the cosine because that's the primary trigonometric function. And then I flip it. So the secant of theta is 7 over the square root of 45. And they're going to want me to simplify this. And simplifying means don't leave a radical in the denominator and simplify your radical if you can. Now, if you notice, the square root of 45 could have been written as the square root of 9 and the square root of 5, which is 3 radical 5. Okay, I'm going to go up here because I just need more space. So that the secant of theta then turns out to be 7 over 3 radical 5. So we've made the radical a simpler number because we've broken it down. Do you understand how all the topics that we did this term, one led into the other? We went into a whole thing about simplifying radicals, but we're still not finished with this Because we have a radical 5 in the denominator. Now, this is not a binomial, it's a monomial. So all I have to do is multiply by the square root of 5 over the square root of 5. And we know the square root of 5 times the square root of 5, that'll just give me 5. So the bottom will come out to be 3 times 5, which is 15. And the top is 7 radical 5 over 15. And this is the simplify. We can't do anything between 7 and 15. They're not simplified. Can you get your calculator to do this? If you have your calculator in something called Math Print, most of them, you go to your settings, to your let me look at my calculator, to the mode, and go to, if you have a lot of the calculators have this something called Math Print, MTHPRINT. If you pick that mode and you put in something like this 7 over radical 45, it will simplify it. If it's in regular mode, it will put it in decimal form. If it's in Math Print mode, it'll just simplify it. Now, if you're still not sure if your calculator can do that, you can always ask me before class tomorrow.
Professor,
Yes.
why didn't you simplify the b equals square root 45? Because if you did, you would have gotten 3 square root 5.
I could have done it right at the beginning, right over here. I did it later instead of.
Would it be the same answer if I did in the beginning?
Absolutely.
Oh,
Because,
okay.
yeah, if you noticed, I did it here. I changed the square root of 45 to 3 radical 5 over here. I probably should have done it, you're right at the beginning, as soon as I saw it. But again, this will be your final answer.
Professor, so while I was taking the quiz, I just wrote down the question that I found hard. And one of them was like find the like the COST and then it had like another T. So I was like, what is that? Because I've never seen that before.
Okay, wait, let me erase this and let me see if I can. I think they just used a T instead of a theta. Usually they use. Can you read me the rest of the question?
I didn't like fully write it down, but I just remember that it was like
let me see if I can
find the COSTT, something like that. I don't remember.
Let me see. I'm looking for an old exam and seeing if I can find something like that. A minute or two. Right. Oh, I think this might be the question, or it's going to be something similar to this. Sine t equals -2/7. Is this the question? And cosine t equals -3 radical 5. over 7, find cosecant t. Something like that, right, Ashley?
Yeah, I think so. Yeah, I think it is.
Okay. So for some reason, usually they use, if you notice there's a space, the letter that's next to the word sine or the cosine or the cosecant, that's the name of the angle. In other words, they drew a triangle and they called this angle T. Why did they do that? I don't know. But all this is saying is they're telling you that the sine of this angle is -2/7. They're giving you what the sine of the angle is. And they're telling you what the cosine of the angle is. It's -3 radical 5/7. And they're asking you what is the cosecant of t. And really all that's being asked here is, do you know what the cosecant is? How do you find the cosecant? What do you know about the cosecant? Anybody? Anybody know anything about the cosecant? Nobody knows anything about the cosecant? How do we find the cosecant of an angle? What did we say we had to do?
It would be hypotenuse over opposite.
Well, yes. How do you know that? Kachira.
Isn't that the rule? Like just
Yeah.
hypotenuse?
But where did we get that from? Do you remember how we got? She's saying that the cosecant is the hypotenuse over the opposite. What was
Is it
it?
the SOHCAHTOA? The
It's a reciprocal. What is it the reciprocal of, Cheryl? I see you wrote reciprocal. What is it the reciprocal of?
opposite?
It's what is it? But it's a reciprocal. Is it the reciprocal? Okay, let's go. I see this is something that I hasn't penetrated.
Miss Pearl, it's Messiah. Cosine is adjacent over hypotenuse, right?
Right.
So wouldn't it be a hypotenuse over adjacent? Or is that wrong?
Okay. Well, you're on the right track, but you have to remember there's sine, there's cosine, and there's tangent. And next to them, there'll always be a letter. Usually it's a theta, but it could be an A, it could be a B. I'm just writing these down. Sine, cosine, and tangent. Those are the primary ones. Those are the ones you've got to know. Those are the ones that we use SOHCAHTOA for. That the sine is the opposite over hypotenuse. The cosine is the adjacent over hypotenuse, which is what you just told me, Messiah. That was perfect. And the tangent is opposite over adjacent. Those you have to know. SOHCAHTOA.
Okay, so so what is it called? How do you pronounce it again? So secant is the reciprocal of sine, right?
Okay, so this is called cosecant. It starts with, there's a cosecant, there's a secant, which is SEC, and then there's the cotangent, which is easy. Cotangent, just put a co in front of it. The other two, so there are 3 more things. Aside from the sine, the cosine, and the tangent, there's the cosecant, the secant, and the cotangent. And each one of those last three are one of the first ones that we talked about, one of the primary ones where we flip it over.
Okay, so the cosecant is the sign, is the opposite of the sin.
Right. And remember how I told you to remember that? The cosine pairs up with the sine. That I know then in the two pairs, the primary one and the secondary one will start with C and one will start with S. So since the sine starts with S, its pair is the cosecant, which means that you get the cosecant by flipping over the sine. You get the secant, but remember this one starts with C, so this one has to start with S. You get the secant by flipping over the cosine. And you get the cotangent by flipping over the tangent. That's why when you said that the cosecant is the opposite over that, the hypotenuse over the opposite, that's because if the sine is opposite over hypotenuse, its cosecant has to be hypotenuse over opposite. Now in this case, in this particular example, they told us what the sine is. They told us what the sine is, they even told us what the cosine is. And they asked me to find out what the cosecant is. Now I know the cosecant is the reciprocal of the sine. So the cosecant in this case is going to have to be -7/2. Just flip this one over. Not this one, because that would give you secant. And we don't want secant, we want cosecant, which pairs up with sine. Does that make more sense to you now, Ashley?
Okay, so that problem is just like identifying which one is, like, you have to know the reciprocal of each one and everything to
Right.
identify.
The whole
Okay.
point in this course, the trigonometry really is not so much mathematics. It's definitions. It's almost English. You have to know what pairs up and what goes with what. If you know that, then the questions are not hard. The only thing that's hard sometimes is using the Pythagorean theorem to figure out the right sides. But then it's just a matter to do opposite over adjacent or hypotenuse over opposite, all that. But literally, this one was an easy one because they just asked you, if they had asked you for secant, it would have been easy also because I would have flipped this one over. But then I would have had a radical in the denominator. I'd have to simplify it. But that's what I would have to do.
I think I kept getting those problems wrong was because I wasn't simplifying them. So
Okay.
now I know that there can be a, what's it called? What's the little thing called where the 5 is in?
The radical.
Yeah, there can be a radical in the denominator.
Right.
Okay.
So yeah, they don't want you to leave the radical in the denominator.
So when you have a question like this where they're asking you to find the CSC, right? That's just them figuring out if you know where each one of these things are. Now, when you find SIN, right, is the reciprocal of CSC, you have to switch the numbers.
Well, usually when you're doing it, the sign, the SIN, is the one that you principally go to. It's in other words, the sine, the cosine, the tangent are our go-to numbers. Those are the ones we find off the triangle. If they don't give it to you, then you have to, and then to get the other three, the cosecant or the secant or the cotangent, that's after you found one of these, depending on what they're asking for. I don't know if I answered your question.
I'm just saying how you see how it says -2/7 in the sign. When
Right.
you found the cosine at the bottom, it's -7/2.
not the cosine,
I mean,
the cosecant,
the cosecant.
right, because it's
So
just,
it was the reciprocal of the sign.
right,
We had to change the numbers around.
right, absolutely. That's why, and you have 3 of these pairs that you get reciprocals of. These cosecant, secant, and cotangent are not so important, except you have to know what they are. Nobody works with them. If somebody ever tells me something about a cosecant, I immediately flip it over and work with sine, because my sine is on my you'll see, this is, I'm sort of leading you into what will happen next term when you go into this more deeply. But you have to know, if you have the sine, that you right away have the cosecant by just flipping it over. If you have the cosecant, you can flip it over and find the sine. They are just reciprocals of each other. Okay, thank you, Cheryl, for telling me that. Okay. Are we pretty much set on this? Try some more of these problems again. Ashley, I'm trying to think where I can get you some more. Look on the practice final also, because there'll be problems like this also, and make sure you know how to do them, okay?
Okay. I'm
Remember,
just scared to
there's
like
two-
do them wrong, because then the grade on the practice.
Okay, so here's the story. Don't be afraid to do them wrong. Better to do them and get them wrong than not to do them. So the grade, first of all, the grade on if you want me to reset any of the only thing I will never reset is a midterm and a final. I can't get you started and say, oh, you don't like my I don't like my final grade, so can I take it again? No, that's not going to happen. But any other test. Now I gave you 2 chances to do the practice final and that test on conics and trigonometry. If you did it twice and you're still not happy with your grade, just email me and I'll reset it and I'll give you a 3rd chance. So don't be afraid to try something. Try it so that you know where you need help. Okay?
Okay. Thank you, Professor.
Okay.
Thanks, Professor.
I have to tell you, for me, the best thing I see is when people are responding and doing the work. In the end, that's what's going to stick with you. Yeah, I need to give you a grade. Obviously, I have to give you a grade. But I know what I really have to do is prepare you for your next course. And the more of these problems that you do, the more of the problems you do, the better you're going to be prepared for next term. It just sticks better. If you did it 3 times, it's going to go out of your mind. But if you did it 20 times, it's going to be there. SOHCAHTOA, if you did SOHCAHTOA and you said SOHCAHTOA to yourself 20 times, I'm telling you, when you get to Math 151 and your professor says sine, you're going to remember, oh, SOHCAHTOA. Sine is opposite over hypotenuse. That's if you did enough times. Okay? Does anybody need any more questions on the trigonometry, or should I do some other type of questions? I'd like to go on to some other work. Okay?
Are these like the only forms of like trigonometry problems that's going to be on the final exam? Like this type of problem?
Yeah.
Okay. Okay, then that's good.
Yeah, basically, the type of problems, you've seen all the types of problems. They're different, all going to be different numbers, but the type is going to be the same. Okay, so let's look at something else. Let me see what I have on my. Okay. Let's do some problems that involve radicals, square roots, and and imaginary numbers. Let's remember if we, let's go through the type of questions you might have. So let's say you try this question. Simplify this. I'm going to give you a couple of minutes while I take attendance. This is the square root of 18 plus 2 times the square root of 200 plus 6 times the square root of 162. Okay, see if you can write this in simplest form. Are you doing that? I'm going to take attendance. Of course not. Okay, Azia, I know you're here.
Yes.
Good morning.
Good morning.
Nashia Allen. Is Nashia here?
I'm here.
Oh, good. Anna Belkis. Emma? Is Emma here? Messiah, I know you're here because I talked to you. Corey Brown. Not here. April.
Present.
Oh, hi.
Hello.
I can always count on you, April. Thank you.
Okay.
Khadija.
Here.
Good morning. Umar, Cheryl, you said Umar can't come on, right? Yakima?
Yes.
Okay, is Yakima Ellison here? Cheryl, of course, I know you're here. And Stacy, I know you're here. Danisha? Devon, I know you're here. Natalie. Natalie here? Erica?
Good morning, Professor.
Good morning. Jonathan, I know you're here. Luke, is Luke here? Layla? Ashley, of course, I know you're here. Kachira, I know you're here. Jennifer, I know you're here.
Yeah.
Rachel. And Gloria. Okay. Okay, let's see how we go about doing this problem. And this is a very common type of problem where we have radicals and we know we can't add them unless the numbers inside the radicals are the same, what we call like radicals. So we first simplify them. And of course, the square root of 18 can be broken up into 9 and 2. And the square root of 9 is a perfect square, so that becomes 3 radical 2. Then we go to the square root of 200. And 200 is 100 times 2. And 100 is a perfect square. And the square root of 100 is 10. But remember, there was a 2 in front of it to start out with. So now this 2 on the outside can be multiplied by the 10 on the outside because it's outside the radical. So that'll give me 20 radical 2. And finally, the square root of 162 can be broken up into 81 and 2. Notice, once I saw this had a 2 and this had a 2, 161 I'm not so familiar with, but if I divided it by 2, I saw I got 81, and the square root of 81 is 9. But again, I have the 6 from in front of it, so I have to multiply the 6 on the outside with this 9 that's now not inside the radical. So that gives me 54 radical 2. And now all of these are like radicals, so I can add them by adding the numbers in the front, the coefficients. 3 and 20 is 23. 23 and 54 is, I hope I did it right, 77. So this is 77 times square root of 2. And Devana, that's perfect.
Professor, I have one question.
Yes.
Even though, oh, no, I see where you got the 2. Never mind.
Okay, you're okay?
Yeah, no, I see where you got it.
Okay. All right, so let's try another example that has to do with simplifying of radicals. What if I gave you this example?
Can we, after this, can we do one where you subtract the radicals?
Well, the only difference would be that the numbers you, okay, I'll do another one. Let's do another one, okay. Let me put it over here. Let me do one. Here, let's say I had this one. The square root of 50 minus 9 times the square root of 32 minus 2 radical 100. Let's see if you could do that one. Okay, let's work on this now. What do we do with the square root of 50? Well, 50 is not a perfect square, but if I divide it by 2, I get 25 and 2. So I can break this up into the square root of 25 and the square root of 2. And now the radical 25 I can write as 5. So this becomes 5 radical 2. Okay, so that takes care of this radical 50. Okay, let's look at this one. This has a square root of 32. Now I can break up 32 into 16 and 2. And the square root of 16 is 4. But I have to multiply that by this 9, and 9 times 4 is 36. So this becomes minus 36 radical 2. It's a minus because the sign in between them was minus. Okay, let's go to this one. The square root of 100 is just 10. So this becomes negative 2 times 10, which is negative 20. And there's no net radical next to it because 100 is a perfect square. So when I go to combine them, I can combine the 5 radical 2 minus the 36 radical 2 by doing 5 and negative 36. When I add 5 minus 36, I get negative 31 radical 2 minus 20. I cannot combine this 20 here because these are not like radicals. So not always are you able to combine all of them like we did over here. They all ended up with a radical 2 next to them, so we were able to combine all 3 of them. But here only 2 were like radicals, so I combined those. Again, 5 minus 36 is negative 31, so that became negative 31 radical 2 minus 20. Now, would it have made a difference? You could have put the negative 20 first and then minus the 31 radical 2. The order in which you put these numbers does not matter. And when they're going to write the answer as a multiple choice, they might write this answer or they might write that answer. They're both correct answers. They won't give you both choices because they're both correct. They can't give you 2 correct answers. But this is what you would do. Is that clearer now, Stacia?
Yes, Professor.
Okay. So now let's try another example. Somebody have a question?
Yeah, what's the name of this operation that we're doing right here?
This is called simplifying radicals.
Okay.
Simplifying radicals. And the next question is also simplifying radicals. In other words, the next few questions all have to do with square roots. So let's look at the next type of question. Suppose I gave you this. And I asked you to simplify this. 4 over 9 minus radical 6. What do I do when I have, remember, we don't like to have a radical in the denominator. When it says simplify, you have to get rid of the square root that's in the denominator. We were having that even with our questions on trigonometry. If this goes throughout math. If you have a radical in denominator and you're asked to simplify, then it means you can't leave that radical, that square root in the denominator. Okay, I'm going to give you a couple minutes to think about it and then we'll go over how to do it. Okay, let's look at this now. Again, we mentioned that we don't want to be left with this radical 6 in the denominator. But the denominator is not just one term. This happens to be a binomial. Whenever there's a plus or a minus in between the two numbers, then that makes it two terms rather than one term. And when you have a binomial in your denominator, what you want to multiply by is what we call the conjugate of the binomial. Which is the identical binomial, except since this has a minus, the one we're going to be multiplying by is going to have a plus. In other words, we're going to multiply by 9 plus radical 6. Of course, whatever we do on the denominator, we're going to do the same exact thing in the numerator. Our decision as to what to multiply by is based on what we see in the denominator, in the bottom. But whatever we do in the bottom, we've got to do the exact same thing on the top. Now, when I do this, I like to first do the denominator first, because when I'm multiplying conjugates, I don't have to do a complete FOIL. All I have to do is first and last. So if I do that, I'll do 9 times 9, which is 81. Remember, outer and inner are going to drop out. We don't have to do that because these are conjugates. And negative radical 6 times positive radical 6 is just minus 6. So 81 minus 6 turns out to be 75. The denominator of this is going to be 75. That's good. We said to simplify it, which means don't leave a radical in the denominator. So
And it's gonna be 4 open parentheses 9 plus radical 6.
right. So there are two ways we can write the numerator. We could just write 4 parentheses 9 plus radical 6, just like this. Or, and again, I can't tell you which answer they're going to give you, because sometimes they write the answer this way, or sometimes they distribute. When you have a parentheses, you could distribute. If you distribute, you'll get 4 times 9, which is 36, plus 4 radical 6. Don't forget, you have to multiply this 4 by the radical 6 as well, over 75. So either one of these answers are correct. Again, you can have it in what we call the factored form. In other words, with a parentheses or without the parentheses. Don't forget, when you're removing the parentheses, you have to use the distributive property. Okay? All right, let's look at another type of question that might come up that has to do with radicals. What if I gave you something like this? What if I gave you an equation like this? The square root of 2x plus 8 equals, let's do something, plus 3 equals 7. Let's say I gave you a radical equation and I asked you to solve this equation. I'm going to give you a few minutes to try it on your own. Okay, I see a couple of people have come up with the answer. Let's do it together. The first thing you do when you're solving a radical equation is you isolate the radical, get the radical by itself. This number 3 has to get to the other side, so I'm going to bring it to the other side. And that's going to give me the square root of 2x plus 8 equals 4. Before I go any further, I look at this number. Just like when we have absolute value equations, when we have radical equations, when we have a square root in an equation, the number on the other side has to be a positive number. If it's a negative number, there's no solution. You could stop right there, no solution. But since this is a positive number, we can go further. But remember, what we want to do is get rid of this radical. So we do what's called the square, we square both sides. We multiply each side by itself. So on this side, when we square it, we get the 2x plus 8. Anytime you multiply a radical by itself, you square a radical, it literally gets rid of the radical. It makes the radical disappear. But this side didn't have a radical, so I have to actually multiply by itself. 4 times 4 is 16. But this leaves us a really simple equation to solve now. We subtract 8 from both sides. And this gives me 2x equals 8. And if I divide by 2, I get that my answer is 4. Make sure that you check your answer, just because sometimes we have this concept of an extraneous root. Sometimes you could do the work right, but you're not going to get a right answer. You're going to get an answer that really doesn't work. So check your answer. So 2 times 4 is 8. This is 8 plus 8, which is 16. And the square root of 16 is 4. And 4 plus 3 is 7. So it does check. If you get this on a multiple choice test and you forgot how to do it, just do the check. Check each answer. In order for something to be an answer, it has to check. So you could just take, if there were 4 numbers, you could just take each answer, put it in place of X, and see which one. And you could even use your calculator, but be careful, and you can find the right answer that way as well. Okay, so let's go on to something that has to do with I's. Remember the imaginary unit, I? Let's see if we can do a problem that involves.
The bottom part, just the top.
What? I'm sorry, just the top. I'm leaving the bottom here. I'm trying to do that. Okay, so here's the next problem I'd like you to try. See if you could multiply 5 minus 5i times 9 minus 5i. And again, I'd like you to put these in simplest form. See if you could multiply those two together. Okay, see, we already have an answer. So let's see if we could do it together. When we want to multiply, these are called complex numbers or imaginary numbers. We have to use FOIL because we have a binomial times a binomial. So if we use FOIL, we'll do first 5 times 9, which is 45, outer, which is 5 times negative 5i, which gives us negative 25i. Inner, negative 5i times 9, which is negative 45i. And last, negative 5i times negative 5i, which is plus 25i squared. Don't forget that I times I gives you I squared. And here's the one thing you have to remember. Wherever you see an I squared, not where you see an I, but where you see an I squared equals -1. Replace the I squared by -1. So this will be 25 times -1, which is -25. And now let's combine the like terms. So there's a 45 minus a 25. They don't have any i's next to them, so they get 45 minus 25 is 20. And then we have -25 and -45, which is -70i. And that would be your answer. 20 minus 70i. This is what's called an A plus BI form, where you have the number without the I first and the I number second. A plus BI form. And I see, Cheryl, you got that, and Azia, you got that, great. And so did you, Jennifer, excellent.
I made a mistake with the I squared, professor, so I got 15.
Okay, so be very careful about that. Wherever you have, not where you have an I, the I you leave, but where you have an I squared. And that's, I have to tell you, most common error is people do I times I and they just write I. I times I is I squared. I squared gets replaced with -1. I gets left, I squared gets replaced. That's the main thing you have to remember. Okay, so let's look at another one that has to do with I. What if I asked you to simplify this? Sometimes they say divide or perform the indicated operation, but most of the time they just say simplify. 5 plus I over -8 minus 2i. This is a fraction with i's, and just like you don't want a radical in the denominator, this I is really a radical. It means the square root of -1. So we don't want an I in our denominator. See if you could rationalize the denominator here. So, or as I say, simplify. I'll give you a few minutes for that. Okay, I see, Luke, that you came on. Okay, I see I'm getting some answers already. So that means that you have, we're ready to do them. Just like we had before when we had the square root in the denominator, here we always decide what we're going to do based on what's in the denominator. Again, these are two terms, so we have to multiply by the conjugate of -8 minus 2i. And remember, the conjugate means the same exact binomial, except the sign between the two terms is switched. So the conjugate is going to be -8 plus 2i. And I'm going to do that both on the top and on the bottom. Some of you have calculators, and your calculators can do this also. If you have a calculator that does it, fine. But I'm doing it as for those of us who want to know how to do it without a calculator, and also not all their calculators work that way. So again, just like I like to do the denominator first to see that I get just a plain number. So if I do multiply, these are conjugates. Remember, conjugates are easy to multiply because you only have to do first and last. So you do -8 times -8, which is positive 64. Remember, outer and inner are going to cancel out. We don't have to do it. Last, -2i times positive 2i is -4i squared. And again, wherever I see that I squared, I put a -1. So this actually becomes 64 plus 4, because -4 times -1 is positive 4. So my denominator ends up being 68. Okay, what about the top? Now the top are not conjugates, so I have to actually do the whole FOIL. Okay, here we are. I'm going to go back over here. So let's do the FOIL. First, 5 times -8 is -40. Outer, 5 times 2i is 10i. Inner, plus I times -8 is -8i. And finally, positive I times positive 2i is positive 2i squared. Remember, I times I always gives you I squared, and wherever I have an I squared, it becomes a -1. So this becomes 2 times -1, which is -2. And I can then now combine the like terms. So I'm going to have -40 and -2 is -42. And 10i minus 8i is positive 2i. Now, usually the way we leave these answers is in what we call A plus BI form. We separate it into two pieces. We put each of the numbers, -42 over 68 and 2i over 68. And you try to reduce each of these. Now, over here, I think they both divide by 4. No, 42 does not divide by 4. We can just divide by 2. Dividing the top by 2, I get -21 over 34. And this I can also divide by 2, and that gives me I over 34. And that's your answer in A plus BI form. That's the way they usually want the answer. Negative 21 over 34 plus I over 34. Just be careful here. Yeah, I see. Azia, what you did is you put them together. You wrote negative 21 plus I over 34. That is also correct. This is what's called A plus BI form, where you separate them, but you could have put them both together, and that would be also correct. Again, with both of these type of the questions, you have to just look at the answers, because sometimes they put the answer this way. That's most likely the way they put it, but sometimes they put it this way. I think that pretty much takes care of the chapter on radicals. We added and subtracted. We talked about dividing, multiplying. We worked with I's. Let me just do 2 questions as a review on the conic sections. And tomorrow we'll finish going over conic sections, maybe do a little bit more with logs and any kind of questions that you want to ask me. Again, if there's anything that's really bothering you, please bring it up tomorrow in class. Okay, so I'm going to erase this one. And I'm going to put 2 different examples on the board right now. One looks like this. 25x squared plus 9y squared equals 225. That's one question. And the other question I want to put on is this one. X squared over 16 minus y squared over 100 equals 1. These are both examples of questions that are asked about graphing. These are 2 of the equations we get. They're quadratic equations. They're equations that we get that give us one of the 4 types of conic sections. Now, the 4 types of conic sections that we have, can I erase this now? Is anybody still copying? Okay. If you remember, the 4 types of conic sections we had were circles, parabola, ellipse, and the last type was a hyperbola. We might not have listed them in this order, but those are the 4. One of the questions you could be asked is, I'm giving you quadratic equations with x's and y's. Does it represent a circle? Does it represent a parabola, etc.? And you should be able to recognize that this one, the 25x squared plus the 9y squared, which has an x squared and a y squared term in it, but the number in front of the x squared and the number in front of the y squared, and sometimes it's on top and sometimes it's on the bottom, but the 2 numbers are not the same. In other words, the coefficient here is 25 and the coefficient of the y squared is 9. That makes this an ellipse. This one also has an x squared and a y squared in it, And the two coefficients are different, but it doesn't matter in this case because the main thing that you see is it has a minus. This has a plus in it. Both the circle and the ellipse have pluses. The hyperbola has a minus. So the question is, name the type of figure or conic section. This one would be an ellipse. Again, when there's an x squared plus a y squared term, it'll either be a circle or an ellipse, but it's an ellipse when these two numbers are different. When you have an x squared and a y squared, but a minus in between them, that's for sure a hyperbola. If you have just an x squared, but no y squared, you just have a plain y, there's no y squared, that's when you're going to get a parabola. So let's look at this ellipse and this hyperbola and see if we could sketch them. This is not in standard format. When it's not in standard format, we first want to put it into standard format. To put it into standard format, you have to divide, the number on the other side has to be equal to 1. So if this number is not equal to 1, you divide by that number. Number on that one, that is in standard format because it has a 1 on the other side. But if I divide this by this number, I have to divide everything by that number. So I'm dividing everything by the 225. And I reduce. Now 25 into 225 goes 9 times. So this becomes x squared over 9. And 9 into 225, if you do it on your calculator, you get 25. And this, of course, becomes 1. So this is our ellipse written in standard form. The reason we want it in standard form because the number under the x squared, which is called the a squared, is going to give us the x-intercept. The a squared in this case is 9, which means my a could be either plus or minus 3, which means that when you're going to be drawing it, you're going to go to 3 on the positive 3 on the x and negative 3 on the x. These are your x-intercepts. Because your a squared was 9 meant your a could either have been positive 3 or negative 3. The b squared is the number that's underneath the y squared. In this case, it's 25, which means your b could be either positive or negative 5. The square root of 25 is 5, which means your y-intercepts 1, 2, 3, 4, 5. And negative 1. And once you have these 4 points, you can just connect them, and here's your ellipse. So all you have to do is find your 2 x-intercepts, your 2 y-intercepts, and then you can draw it. Of course, what they're going to give you is a picture, and you're going to have to pick out the correct picture, the one whose x-intercepts are 3. And you have to be careful because the pictures are not always so clear. Make sure you count those little tick marks so you know that they're crossing at the right point. For the hyperbola, it looks very similar. If you look at the setup, the only difference being there's a minus in between them. The one that's positive is the one that's going to have intercepts. The one that's negative has no intercepts. In this case, sometimes it's the x squared that's positive, sometimes it's a y squared that's positive. In this case, the x squared is positive, which means we know the a squared is 16, that the a is plus or minus 4, tells me that I'm going to have two x-intercepts, one at 4 and one at -4. There is no y-intercept because the y squared is negative. It's minus y squared over 100. So when I draw this, I'm only going to be crossing the x-axis. And the figure we get are two back-to-back u's through those numbers. Now, sometimes they're narrow u's, sometimes they're wider, but you don't have to know how to do that. You just have to remember where they're crossing, that this one is crossing the x-axis at -4 and 4. So that's what you need to know about the ellipse and the hyperbola. We'll go over the circle and the parabola tomorrow. We'll do some problems with that. Okay, I think I'm gonna leave you unless somebody has a question they want to ask me.
My problem was when I was taking the practice exam, I would get the right answer of what it would be. I would know it would be a hyperbola, but they would try to play you and put two things that would look like this. And then now I see how I got it wrong because I didn't count the lines
You have to count those.
on the graph on the test. I just put the one that looked like more as a hyperbola, and that's why I got it wrong.
Right. And sometimes they could put all 4 of the pictures would be hyperbolas, and some could be crossing the x-axis, some could be crossing the y-axis. What they're looking for is, are you getting the right x? And the same thing with the ellipse. Make sure you're getting the ones that are crossing at the right places. That's the important thing to look for on these questions. Okay, any other questions? Okay, so I'll see you tomorrow. Melissa, you're taking, let me make you host. I didn't do that yet. I forgot. Okay, I'm going to stop the recording.
Have a good day, Professor.
Thank you,
too.
Professor.
Thank you.
Okay,